Good evening, viewers. Today we'll understand about functional decomposition of a mechanical spray. This is the bottle that we are going to decompose, and this is the chart that we have drawn. We'll look into it further. Entire disassembled mechanical spray, where this is a reservoir, this is actually a cap to the nozzle, and this is actually this part which acts as the reciprocating pump. We'll see its functioning further. This is the nozzle, and this threaded part sits on the reservoir top. This is the handle which actually controls this reciprocating pump, and this actually is the pipe that connects the fluid in the reservoir to the nozzle. So coming to the functioning of the mechanical spray, this and there are two other parts inside this casing of the nozzle where the plunger mechanism acts. This blue part is actually an extension to the plunger mechanism, so that this actually is controlled by this handle, and so it becomes a mechanical spray. This plunger, when actually force is applied, this ball valve, when attached to the spring, actually goes inside, taking into the water in the fluid. That is a pressure difference created at this position, so that water gets sucked into this reservoir, into this plunger, and then when the force is reduced, the water again changes its direction towards this nozzle. The nozzle consists actually of small segmented openings, so that water, when pressurized, comes in the form of a spray. And this nozzle also supports a cap, so that there can be some valuable liquids like fresheners or cleaning fluids like colin and harpic, so that they actually have high volatility, not to actually cause their displacement. This cap is actually used. These two diagrams actually make us understand of how the fluid actually displaces from the reservoir in towards the nozzle, and this plunger mechanism is controlled by the handle. In fact, the extension is also provided to this plunger mechanism in order to make a easy approach towards the use of the fluid inside the reservoir. The plunger mechanism, the parts of the plunger mechanism look like this somewhat, and this is actually controlled by this blue part, and this is the ball valve that I was talking about. The ball valve is actually connected with the spring, and when this pushes the ball valve inside, it creates a pressure difference. Thereby the water in this reservoir goes into this plunger, a little part, not much, depending upon the volume supported by the plunger, and then when subjected to pressure, the flow direction reverses towards the nozzle, and thereby the serrated openings that are at the end of the nozzle will cause the fluid to disperse, thereby allows the water to come in the water or fluid to come in the form of a spray. Functional decomposition chart of a mechanical spray. Here the legends, three legends being the mechanical energy, which is denoted by a solid arrow, the fluid, which is denoted by a segmented arrow, and the signal for the motion is denoted by a curved arrow or a sinusoidal arrow. So the different parts, different actions of the mechanical spray are given in this tables. The first one is actually to suck in the fluid, actually to cause a pressure difference. This is actually the function or the action of causing a pressure difference. The second function is holding the fluid, and simultaneously the other function also will be filling the plunger. And how these two actions are connected to the first one is about the is through the mechanical energy that we give from our hand, and this that is from the mechanical energy, and also the fluid also gets stored in. That is, the fluid which is caused to go towards the plunger also needs to be held in the position. Similarly, the signal to fill in the plunger will also should be identified. That is, if the plunger is completely filled, then the next action would be pushing the fluid towards the nozzle. That is, this is the action of reversing the direction of flow. from reservoir to the plunger, that is reversed towards plunger to nozzle. Also, the spraying of the fluid is also another action where this can only be created with a high pressure difference and the serrated or decreasing the cross section area of the fluid, because as the cross section of area is decreased, the fluid also disperses into tiny molecular structure or tiny droplet structure, and the resulting spray is that we get. So the another action after the spraying of fluid is the release of plunger. That is, this releasing of plunger should be an automatic action. So we use a spring and a ball valve that supports this releasing of a plunger inherently, so that we do not have to cause any supporting action for this release of plunger. Then sucking in the fluid, again, which is the action of causing a pressure difference near the plunger. Thereby the cycle is repeated for us to create multiple times of spraying at any particular part. That's all, viewers. This is the functional decomposition of a mechanical spray, and this that I am revisiting the diagram and the other important parts. This is the main important part where we need to concentrate everything, and these can all be subjected to aesthetics, but this plunger part is actually where the amount of the spray, the amount of fluid that can be sprayed, actually depends upon the volume of this plunger that it can support. This is it, viewers. Thank you for watching.